Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is initialization by a copy constructor. Before proceeding, make sure that you have already watched these other videos first. A class can define multiple constructor functions and then rely on function overloading to choose which one gets performed when an object is being instantiated. One of the commonly programmed overloads of a constructor is the copy constructor. A copy constructor has exactly one parameter, which is a constant reference to some other object of the same type. The purpose of a copy constructor is to copy that object's data into this object. The copy constructor will automatically get called whenever that type of object is being passed into a function, passed by value. The object that's in the client code will get copied by the copy constructor, copied into the function's parameter variable. Initialization is when a variable is having its data type defined and being given an initial value, all in the same one code line. In C++, there's more than one syntax form that you could use for an initialization statement. Implicit initialization syntax uses this equal sign symbol immediately before the initialization value. If the variable's data type is some kind of object, then this implicit initialization will automatically cause the copy constructor function to get called, automatically passing the right-hand side expression as the copy constructor function's parameter. In explicit initialization syntax, the programmer doesn't use the equal sign symbol. Instead, the initial value is programmed to be within parentheses. Again, if the variable's data type is some kind of object, then explicit initialization will automatically call the copy constructor function. Although a programmer doesn't write member functions for a primitive type, like int, notice that the primitive uses the same implicit and explicit initialization syntaxes. In our previous example, we showed an object being initialized from a compiler temporary. You can do that with this primitive too. It's essentially converting from some other data type into a compiler temporary that's an int. You can imagine it being as if the C++ language has already defined some built-in one-parameter constructor function, which can convert from this float into this int. Some programmers even like to do this on purpose as an alternative to traditional type casting. Similarly, you can imagine the C++ language having a built-in zero-parameter constructor function, which constructs the compiler temporary to be some form of zero. However, that zero-parameter form can only be used in implicit initialization syntax. If the programmer doesn't manually program a copy constructor for his custom class, then the compiler will automatically implement a copy constructor for him. But the compiler's implementation will only do a shallow bitwise copying of primitive data members and a copy constructor of the other members. For that reason, both copy construction and overloaded assignment should be added to a class definition if your class owns any dynamically allocated memory. If the compiler is going to automatically provide an implementation for something like a copy constructor, but you don't want your clients to be able to use them, then you can declare that function as private within your class definition, but then not provide any function implementation. Don't confuse the concept of implicit initialization with the concept of assignment, even though they both use the equal sign symbol. A statement will be an ordinary assignment statement if there is no data type being specified in that code line. An ordinary assignment calls the assignment operator instead of doing any copy construction.